Hey guys, I'm back with another question from Fourier series, that is module 2 September 20 M3 exam. The question is, find the Fourier series of f of x is equal to pi minus x by 2 in the interval 0 to pi. So before going to solutions, please subscribe to our channel. So for what is the Fourier series expansion? When the interval is given in terms of pi, the expansion is f of x is equal to a0 by 2 plus summation from 1 to infinity an cos nx plus summation 1 to infinity bn sin nx. So we need to find a0, an and bn which depend upon f of x. So what is a0? a0 is equal to 1 by pi summation 0 to 2 pi f of x dx. So this is the formula for a0. a0 is some integration f of x dx from 0 to 2 pi, whatever the interval is given, and 1 over pi. So if you substitute f of x here, what will you get? 1 over pi integration from 0 to 2 pi, pi minus x by 2, I can write it as pi by 2 minus x by 2 with respect to x, integration with respect to x. So what will you get? 1 by pi as it is. Integration of pi by 2, integration of constant is pi by 2 as it is into x minus integration of x is x square by 2 and this 2 as it is. Okay, this is from where to where? From 0 to 2 pi. So what will you get? 1 by pi, if you substitute upper limit in place of x, what will you get? 2 pi into pi is 2 pi square by 2, right? Minus, if you substitute 2 pi here, what will you get? 2 pi whole square is 4 pi square by 2 into 2 is 4. Minus, if you substitute lower limit in place of x here, you get 0 and 0. 0 minus 0. So 2 pi square by 2 is just pi square, 4 pi square by 4 is just pi square, pi square minus pi square is 0, 0 minus 0 is 0, 0 into 1 by pi is a0 is 0. Okay, so we found out a0 which is equal to 0. So next let's find out an. So next an, what is the formula for an? An is equal to again 1 by pi integration from 0 to 2 pi f of x into whatever the coefficient of an is here, that you have to write it, cos nx dx. So what will you get? 1 by pi as it is, integration from 0 to 2 pi. What is f of x? f of x is pi by 2 minus x by 2 into cos nx dx. So this is simply a u into v integration. What is the integration of u into v? Integration u dot v is equal to u into integration v minus u dash into 2 times integration v plus u double dash into 2 3 times integration v minus dash dash dash. This goes on. The formula goes on. This formula works only when u is a polynomial, which is the case here. So we only need these first two terms. So what will you get? 1 by pi as it is, open a bracket, u into integration v. U is pi by 2 minus x by 2. Integration cos nx is sin nx by n minus u dash. U dash is differentiation of this. Differentiation of pi by 2 is 0. Differentiation of minus x by 2 is minus 1 by 2. Into 2 times integration of cos nx is, or 1 time integration of sin nx, which is minus cos nx by n, and this n will become n square. Okay. Plus if you integrate this, it will become 0. So only this much is enough. So from 0 to 2 pi. This is from 0 to 2 pi. So let's evaluate limits by substituting upper limit in place of x minus lower limit in place of x. So 1 by pi integration for upper limit, substitute 2 by pi, 2 pi in place of x here. What will you get? Pi by 2 minus, if you substitute 2 pi here, 2 pi by 2 is just pi sine, if you substitute 2 pi here, you will get 2n pi by n minus into minus plus minus 1 by 2 cos, if you substitute 2 pi here, 2n pi by n square. This is for upper limit, minus if you substitute 0 here, you will get pi by 2 sine, if you substitute 0 here, you will get 0 by n, minus into minus plus into minus minus 1 by 2 cos, if you substitute 0 here, cos 0 by n square. Okay, so in this sine 2n pi is 0, cos 2n pi is 1, sine 0 is 0, cos 0 is 1. Okay, so what will you get? Finally 1 by pi, this is 0, this is 1, so we will get minus 1 by 2n square, this is 0, minus into minus plus 1 by 2n square. So minus 1 by 2n square plus 1 by 2n square is 0. So an is also 0 for this question. So an is also 0. Okay, so let's find bn. So next find bn. So bn is again 1 by pi integration from 0 to 2 pi into f of x. What is coefficient of bn? Sin nx. So you have to multiply sin nx to the f of x with respect to x, integration from 0 to 2 pi. So what will you get? 1 by pi integration from 0 to 2 pi, f of x is pi by 2 minus x by 2 into sin nx dx. So this is again integration u into v. What is integration u into v? Integration u dot v is u into integration v minus u dash into 2 times integration v plus dot dot dot. We only need 2 terms. Okay. So how do we get here? 1 by pi u into integration v. U is pi by 2 minus x by 2. Integration v means integration sin nx. Integration sin nx is minus cos nx by n minus u dash is differentiation of pi by 2 minus x by 2, which is 0 minus 1 by 2. 2 times integration of sin nx is 1 time integration of cos nx, which is sin nx by n. This n will become n square. This minus as it is you have to give. So this is from where to where? 0 to 2 pi. So if you evaluate limits by substituting upper limit in place of x here, what will you get? 1 by pi by 2 minus, if you substitute 2 pi here, 2 pi by 2 is just pi, right? This minus, I'll keep it here, minus cos 2n pi, okay, by n, minus into minus plus into minus minus, 1 by 2 sine, if you substitute 2 pi here, you will get 2n pi by n square. So this is for upper limit, minus for lower limit you substitute 0 here. Substitute 0 here, pi by 2 minus 0 is pi by 2 minus cos, if you substitute 0 here, 0 by n, or I'll write this minus here. Okay, minus into minus plus into minus minus, 1 by 2 sine, if you substitute 0 here, 0 by n square. So this is the limits. So what do you get? Cos 2n pi is 1, sin 2n pi is 0, cos 0 is 1, sin 0 is 0. So this will be 1 by pi, this is 1, right? So pi by 2 minus pi is minus pi by 2, minus into minus plus, so we will get pi by 2n. This is 1, right? So you will get pi by 2n, this entire term. This is 0, minus to minus plus pi by 2n. In the numerator you have just pi, into 1 is pi, in the denominator you have 2 into 1 is 2. So what will you get? 1 by pi by 2n plus pi by 2n is 2 pi by 2n. This 2 to this pi get cancelled. So bn is just 1 by n. So bn for this example is 1 by n. So now that we have found out a0, an and bn, let's substitute them in the Fourier series expansion. Substituting a0, an and bn in f of x, we will get f of x is equal to, so a0 is 0 plus an is 0, so this entire term will become 0 plus summation from 1 to infinity, bn is 1 by n, so this is sin nx by n. So Fourier series expansion of pi minus x by 2 in the interval 0 to 2 pi is summation 1 to infinity sin nx by n. Okay, this is the answer, you can leave it here, but in the question they have asked us to show 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 is plus dash 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 is equal to pi by 4. So we need to show this series is equal to pi by 4 by using this Fourier series expansion. Okay, how can we do that? So f of x means it is pi minus x by 2, right? So this is pi minus x by 2. Okay, and if you substitute x is equal to 0, this entire term will become 0 because sin 0 is 0. So we cannot substitute x is equal to 0. So let's substitute x is equal to pi by 2. So that we will get this entire term in the numerator as 1. Okay. So substituting x is equal to pi by 2. What will you get? Pi minus pi by 2 is equal to, and we will open this summation. So substituting n is equal to 1, what will you get? Sin 1x by 1, right? So we are substituting x equal to pi by 2. So it is sin pi by 2 by 1 plus sin 2 into pi by 2 by 2 plus sin 3 into pi by 2 by 2, 3 plus sin 4 into pi by 2 by 4 plus sin 5 into pi by 2 by 5. This goes on and on like till infinity. Okay. So what we get here? Pi minus pi by 2 is pi by 2. Pi by 2 by 2 is pi by 4. Okay, sin pi by 2 is 1. 1 by 1 is 1. Okay, 2 and 2 get cancelled. Sin pi is 0. So all the even terms will become 0. If 2 and 2 get cancelled, sin 2 pi is 0. Okay, sin 6 pi will be 0. Sin 8 pi will be 0. Only the odd terms will remain. And sin pi by 2 is plus 1. Sin 3 pi by 2 is minus 1 by 3. This 3 as it is. Sin 5 pi by 2 is again plus 1. So plus 1 by 5. Minus 1 by 7. Plus dash dash dash. So substituting x is equal to pi by 2 in this Fourier series expansion gives us this series is equal to pi by 4. Okay. So if you want to practice more questions on Fourier series and learn how to substitute what values here, you can visit our VTU M3 course that we have done, which includes all the solved question papers and all the basics such as integration and evaluating limits that is required for Fourier series and the Laplace series and Fourier transform and all your M3. The link to the course is in the description.